let's begin. Tonight, I am JT, not normally, but tonight I am. And tonight I'm going to be talking about imaging effects with Imager. So in the past, I have given a couple of talks about using Imager to actually compose images, bring multiple image pieces together from different sources, and also drawing, generating visual text, or text that's images or image-based. Tonight I thought we'd go into imaging effects. We did a little poll last month and everybody thought that was a good idea. So, but before we begin with that, I thought I should give a quick 2-second recap of Imager so that you have some basic fundamentals of how does that work. So I'm just going to do it in a single slide. Basically, you use Imager, and Imager, for those of you who are not familiar, is basically Perl's version of Photoshop. Almost anything you can do in Photoshop, you can do in Imager from Perl. So you just install that, and then you use Imager, and Imager is actually quite a bit faster than almost any other mechanism you can use in Perl to draw stuff. So it's by my own calculations, it's roughly 10 times faster than ImageMagick. To create a new image, you just Imager new, and then the X size and Y size. And then if you wanted to load in an image, you simply give the path to the file and load that. Scaling images, you can do all different kinds of stuff. If you just specify X pixels or Y pixels, it'll scale proportionally. If you want to scale non-proportionally, as I'm doing here, you put in type non-prop and it'll do that. You can draw boxes and circles and lines and polygons and all kinds of crazy stuff. So I just gave a quick example of drawing a box here. Then of course you need to be able to write out files. So you don't really need to know much about Imager. You just need to know some basics so that when you see it in my various slides, you're not like, well, what is he doing there? Oh, he's loading a file. I see. Okay. So that's it. Any questions so far?
All right. I assume it infers the output type by extension or something?
Yes, you can specify an output type, and there are other things on a per type basis. So like if you're doing a JPEG, you can specify the image quality level, that sort of thing, as optional parameters there. But each file type has its own list of things that you can do there. If you do not specify a type, it goes by the file extension. So
does this have its own imaging thing? Is it based on like GD or something else? Or?
It's its own thing. It's all written in C, and it's its own static or standalone library system. It's not based on GD or ImageMagick or GhostScript or any of the others. Can one of you hit the door there? Thank you. So yeah, it's its own thing.
Okay.
Any other questions? Okay. Cool. So by the end of tonight, I want to be able to take the image on the left and turn it into the image on the right. There are a number of things going on there which are maybe not obvious. So I thought maybe we would quickly take a look at those two side by side, and you guys could tell me what is it that you see. What's the difference? If you want, we can go back to the bigger ones.
Hex crop, beveled edge.
Okay, we got hex crop and beveled edge. What else? See how many you can find.
Boy, the brightness really changed.
Yeah, you brightened up the side.
Okay, brightness.
Of this. Yeah.
Anything else?
Shadow.
Yes. Yeah, there's a shadow there.
Oh yeah.
So that's exactly it. It's masked so that it has a hex shape with rounded corners. It is beveled edges, so it makes it look three-dimensional a little bit, like it stands off the screen. It has a shadow on the image on the building, so the building is casting a shadow onto the ground. And then also, as I think you pointed out, that that the building is a little bit brighter. It's a little bit more lit up.
It's like it has a light source.
Yeah.
And then all those effects are derived from a flat image.
That's right.
You don't have a separate 3D model.
There's no 3D rendering going on here at all. This is all fancy tricks using Imager, which I'm going to show you. So yeah, we'll get through all of this. All right, so let's start simple and just talk about masks. You were calling it cropping. So basically, all images, no matter what, are going to be rectangular in shape. They're all, you know, an XY Cartesian plane. But if you want it to look like it is a different shape, you can use a mask. And so basically what I'm doing here is I'm making that the outer pixels on this image transparent so that you only see the pixels that I want you to see, and therefore that image now looks like it's hexagonal rather than square. Does that make sense? So a mask is how you pull that off. So you create a mask using something like Photoshop or GIMP. It should be transparent. The transparent part should be black or clear in the image, and the part that you want to show up, so back here we want the 2 to show up, then the hex part of the 2 needs to be white. So that way when we apply the mask, that part will be displayed, and anything that's either black or clear will be see-through essentially. And then we simply apply the mask once we have built it.
Do they use the word layer at all for any of that?
The layers are a human level concept.
Right.
They're not.
It's a GUI, like what we see when you're using Photoshop. You apply layers.
Exactly.
But in coding, it's mask.
No, masks exist in Photoshop as well.
Okay.
You would put a mask into a layer.
Okay.
Layers are only there for humans to organize stuff, so that you can keep everything organized and turn stuff on and off and all that kind of stuff. It's not a concept that's necessary when you're programming something. So a mask is simply a way to say I want a certain part of this image to be visible, and that's it. And you can do funky effects with that too. You can make things look half-toned or dithered by having certain dots on and off rather than having a shape, that sort of thing. So
I almost think of like exposing film. You have a mask.
Yes.
I mean that's the older.
That's exactly it. That's where the term comes from. So yeah. So is everybody comfortable with this so far? Okay, because it's only going to get more complicated from here.
You're asking questions that are already you're in trouble.
Yeah.
That's me.
But no, I want you to understand it so that when we go through this, you're not going, oh, what the hell is going on here? So if you didn't have GIMP or Photoshop, you can build a mask using Imager, of course. So in this case, I'm going to use Imager Draw Hexagon, which is a module I wrote like a year ago or so, and I actually think I might have done a talk on it here. So we're going to create a new image that's going to be 450 by 450 pixels, and then we're going to draw a hexagon in the middle of that image. We're going to make the hexagon white. By default, a 3-channel image, which would be one that does not have transparency, the background will be black in Imager. So if you wanted it to be something else, you'd have to fill that in. But because it's black, we're going to take advantage of that because we want, again, everything that's black will be transparent in a mask, and then the hex is going to be transparent itself, the white part. So we're going to draw a white hex onto a black background here, and then we're going to write that out as mask.png. And that is going to look like this, okay? The one on the left. But as you can see, with Illustrator or Photoshop, I can get a little fancier. For example, when I wrote Imager Draw Hexagon, it's just drawing hexes. I didn't make it do anything fancy like with rounded corners or anything like that. In Illustrator, you can very easily set what do you want for the rounding of a corner. And so I've done that with my hex that I drew in Illustrator. So technically, you could draw that exact same thing with the rounded corners in Imager as well. Just you'd have to end up writing all the code that would figure out the math of how that corner gets rounded and all that kind of stuff. It's a little bit more difficult. And you might even use a mask to create it.
A circle around the corners.
Yes,
Shape it up.
exactly.
Oh, wow. Yeah.
You might even use a mask to create that.
Yeah.
So anyway, that's that. But because I already have Illustrator and I know it very well, and I have Photoshop and I have GIMP, I can very easily do this in those things without creating this in Imager. So I'm going to go ahead and do my masks using Illustrator instead.
Is it? Sorry, on the Illustrator one, is it just to sort of an illusion that it looks like the edges of the Illustrator one bow out slightly. Is that just an effect?
That's an optical illusion. They're not actually bowing.
Okay.
So yeah.
That's just
Yeah. That's just a sign that you're insane. And you should be, the men in white coats will be here shortly.
Fantastic.
Yeah.
Not again.
Does anybody else see that?
That is a good
Nobody
question.
else sees that?
You're the only one.
All right. So again, I'm building this stuff in Illustrator, but you can build it in Imager, of course. So how do you use a mask in Imager? Just like before, we load in a file. So in this case, we're going to load in our mask as one variable, and then we're going to load in our pre-masked image. So in this case, that purple background with the white 2 in the middle, we're going to call that image. And then we're going to create a new blank image. And we're going to put these other 2 images that we just loaded into the new blank image. And I'll explain why we're doing a new blank image in just a second. So then we're going to compose that over the top. And the compose method in Imager has this mask attribute. So you can put in one image as the source image, which is the image that we're going to actually modify. And then we put in another image as the mask, and it does the masking for you. It's all really fancy and easy, and you don't really have to do anything. All you have to do is create the mask and then apply the mask, and you're done. Now, the reason that we created the blank is because by default, these images were all what are called 3-channel images. That means that they do not support transparency. The 4th channel, so it's red, green, blue. The 4th channel is for alpha, or transparency. Can you hit that door, please? So we had to create the 4th one, so that's why we created a blank image, so that we specified how many channels will this image have. It's not just going to have RGB; it's going to have the alpha channel as well for transparency. Okay. All right. Now, if our pre-mask image had alpha transparency, we could have probably just used that. We would still do, instead of doing blank compose mask source image, we would have done image compose mask source image. So image would have been in the same line twice, but because it had transparency, it would have worked. But we don't know for sure whether it had transparency. Technically, I could have checked, but since we're creating a new image anyway, just create a new image. It's not that big a deal. We're not going to overwrite our original image. We're going to create a new one, so just create a blank. Okay, so this is basically what's happening. Visually, I'm going to demonstrate what happened when I wrote that code. So basically, we apply the mask, and then the mask peels away and becomes transparent. Everybody got that? We'll do it one more time. Apply the mask becomes transparent. Okay? So that's effectively what happened when we run that little piece of code there. Very simple. Mm-hmm. Everybody on board? Any questions?
Just can you go back and say, so there's 2 steps: you apply the mask, and the mask becomes transparent.
Yes.
Okay.
So the mask, by applying the mask,
Right.
this little animation here isn't actually being rendered by Imager. I'm rendering it here to show you what's happening. In Imager, that happens in one step.
Right.
It that one line of code right here, blank compose mask,
Okay.
is actually this entire animation that I'm playing there.
Let's those 2 pieces together.
Yep. So it's taking the source image and applying it to our blank image, and then it applies the mask over the top of that, and then it says mask everywhere where it's black becomes transparent.
And for the mask colors, white is the visible portion, black becomes transparent.
Right.
Can you change which color values are opaque and which are transparent, or does it always have to be black and white?
To my knowledge, it always has to be black and white, but maybe you could. I've never tried. That's just
Convention.
It might be easier to think of black and white as morphological values rather than the colors?
Yeah, because that's effectively exactly what you're doing. So white is on, black is off, right? So for this pixel, it's literally going pixel by pixel.
Right.
This pixel on the mask is black, therefore on my original source image, it is off.
So if you had a mask that contained a very dark gray, are you going to get some sort of weird blending effect, or what? Or
That-
just going to treat that as white? Anything that's not a zero value?
Anything that is not a zero value will be visible.
Okay.
It's like candying the binary values, it's different versions of it.
There are ways to do what you're talking about. That's called a rub through.
Okay.
That's a
Where you get
different-
sort of a two.
Where you're getting these kind of layers put together.
Okay.
That's called a rub through. I'm not going to demonstrate that tonight, but that imager is capable of doing rub throughs.
Okay.
So, okay. So there's our animation. So now we want to add a bevel. So we're going to take the image we just created on the left and turn it into the image on the right. We're going to add that nice little bevel. And again, you could create the bevel using Imager, but as I stated before, it's way easier to just do that in Photoshop or Illustrator or GIMP, so I'm just going to do that rather than figure out all the math. So you first have to create the bevel, and then everything except the bevel should be transparent. So this again should be a 4-channel image. Alpha layer is on, and everything should be alpha. Everything should be transparent except the actual bevel part that you're trying to draw.
So you need to make sure that your bevel matches your...
Yes. You either need your bevel to be kind of black and white, or you need it to have some built-in colors for the thing you're beveling, or you will apply the bevel, you make the bevel black and white and you apply it as a partial transparency, which will bring the colors through from the other thing, which is what I'm going to do. So
Is that that's different though from the rub through?
that's different from rub through, yes.
Okay.
So I'll show you that right now. So this is the beveled image that I created. You can see it is all black and white, right? There are no other colors in there. I mean, there's some gray, but there's no purple in here. This is black and white only. There's no green because later we're going to have another image that's green, and this will apply to that, and you'll still see the transition of greens that happen right over this, because we're going to do this as a partial transparency when we apply it. So the code for this is really simple, way simpler than the other thing. First, we're going to load in our bevel image, and then we're going to load in the image that we created on the last step, which is our hex. And then we are simply going to compose the bevel over the top of that hex image that we created, and we're going to change the opacity to 80%. And that's going to give us our nice transition of purples as we look at our bevel. Does that make sense? So, again, here's my little animation to show you what's happening there. Do you see the nice purple sheen that goes through the black right there? You have on the top edge. Yeah. On the top edge, you've got the white. You got the light source on the top left, right, coming down, and you can see that that's not white there. It's like pinks going into purple, right? And then at the bottom, you've got your shadow essentially, and so you're looking at the light purple into dark purple into black, and that's happening rather than being white on the top and black on the bottom. It's because I did 80% transparency, means that when it applied that, it's mixing the color beneath it with the colors that were in my bevel. Does it make sense? It's a fancy little trick, but it's really simple once you know the trick. So, okay. Any questions on that or the code that made this work? Okay. Pretty straightforward so far? Okay, I'm glad you're saying that.
I can tweak it. I couldn't write it.
Well, alright, so when you were working this out,
Yeah?
you just look up bevel and look up opacity, look
No.
up the pronunciation of opacity, which would have stumped me for a while. But, not too hard for you either?
We got to remember, I've been doing imaging for the last 10 years.
Yeah.
So it's different if you're coming into this not being somebody that does imaging. Trying to figure this stuff out would be very difficult. So the complete process that I'm showing you here today took me the better part of a day to do the first time I did it. Okay. However, I have tried to do this in the past and failed. So all in, I probably have a week and a half to 2 weeks worth of effort in on doing this. I've just never been successful until recently. So I would say that it is not necessarily obvious how to do some of this stuff. It is stuff you figure out through playing and trial and error. So for example, when I first created the bevel, I was thinking, oh, well, I'll have to create a color bevel so that it'll match. But then I was realizing that my images have all kinds of different colors all over them, and that would be a total pain in the ass. So then I had to figure a way around that. And the best part about this is to take every piece step by step. Don't try and build the entire process. So do what I'm doing. You create a program here that does just this one step, right? Now, in the end, I have a bigger program that actually does all of these steps all at once, because that way I'm not having to save out to the file system and load back in every time. Just going boom, 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 do all these things. But when you're trying to figure out how this stuff does, doing this is a good thing. The other thing you can do that I do a lot of is if I have a variable like the 0.8 here, for example, I will actually put this in a for loop and just spit out 10 variants of it and see which one looks the best. So it makes it easier to figure this out, especially when it comes to the things that I'm going to show you later, which are far more complicated. This is very easy comparatively. Okay, so any more questions on bevel? Okay. If you got questions, bring them up now, because it's going to get more complicated as we go. This is not a terribly long presentation either, so we don't need to save time or anything like that. So, okay. So now we got to deal with the brightness situation that you pointed out over here. So this is my in that is rendered into the landscape here on the left. It does not yet have a shadow, and it is darker than the image on the right. The image on the right has the shadow and it is brighter, right? So those are the pieces that we have to do. But for right now, let's just focus on the brightness. How would you go about doing this? What do you think the trick is to make this, the foreground part of it, brighter?
Define a mask that is the bounds of the in and then boost its movements or whatever.
Yep, that's exactly right. If you only have this image that's on the left, you'll have to define a mask that is exactly the bounds of the in, and then you'll be able to do some of these other things, like the shadow and the brightness, that sort of stuff. The better way to do it is, of course, to have a separate foreground image. So they are not yet combined, foreground and background, because then you don't have to do the masking part. You can automate the masking part. So then we need to create a color map for brightness, because there's not, you know, if you're just in Photoshop or GIMP, there's a little function that you can say that says brightness, increase brightness. But behind the scenes, it's doing a color map for you. Imager doesn't have a little brightness function. You actually have to create a color map, and I'm going to show you how to do that. And then apply the color map. So, what we're doing here is, again, we're loading in our in file. So that's a very standard thing, easy to do. And then we create our color map. That's the one line right there. Colors equals map int 1.25. So can anybody describe to me what is going on there? What am I doing with that map function right now?
You're going to multiply all the numbers 0 through 255 by 1.25, and you're going to make an array. So you'll have an array of numbers, well, starting with 0, but the next one will be 1.25, and the second one will be 2.5, and the third one will be so on, and 1.5.
Yep, exactly. So we're just making everything 25% brighter, and how we're doing that is simply shifting the value that is already there to be 25% larger than whatever it is. So a color map is simply saying, whatever, colors go from our 256 colors. In modern displays, how we do everything in colors is 256 colors. So there are 256 shades of red, and 256 shades of green, 256 shades of blue, and you combine those to create all the different colors on the spectrum. So a zero value color is black, 255. If all three of them are 255, that's white, right? So what we're doing here is we're saying that we're going to increase the values of all of these by 25%, and it's going to do a color replace. Is this pixel this color? Is this pixel 1, then, or R1? Then if so, we're going to change that from R1 to R25. Does that make sense?
What about 220?
With this, you're gonna wind up with a bunch of colors that push up.
Yep, those will be white.
Okay. Now, like if you're in Photoshop and you're playing with levels, you get like the 3 little sliders and you got your
The histogram?
right.
Yeah.
Is there a way to do that where you can adjust so that you don't get everything washing out?
You have to write your
You
own
have to do the
algorithm.
math.
You have to do the math to make it so that maybe you want to make a threshold. So above this, the percentage, as you get further up closer to 255, the percentage becomes smaller and smaller, right?
Okay.
Basically,
Um,
you would replace that in.
Right. With some other calculation.
Yeah.
Okay.
So yeah, you can write any algorithm that you want here. Now, if you're going to do this with different color values also, we're doing this for red, green, and blue. If you look at the thing down below here, we've got red, green, and blue. I want exactly the same shift across all 3 colors, so therefore I can use the same color map on all 3 of them. Your algorithm might change green. You want it to tint a little bit green because you're making an image about the matrix, and everything has a green tint in the matrix, right? So therefore you might have a different algorithm for green than you have for red and blue. And therefore you need a different color map for each color. So in my case, since we're doing brightness, we're just scaling up all 3 colors at the same interval. So that's it. Pretty straightforward. Any questions?
I don't know my color theory that well, but is there a simpler way to do this using like HSV or some other color mapping like that?
Not in Imager, to my knowledge. There might be. The various examples that you will find online are going to be this. There are other color. There's a whole color thing. You can define colors and all of their properties as an object, each individual color as an object in Imager. And when you do that, you can do really crazy, cool stuff. Like each color can have its own transparency value, things like that. So, and then you can also do something called a fill. And so then the fill will be an algorithm about how it, changes all those things. So I'm sure you can do some pretty crazy things, but as far as if you just wanted to do a quick little brightness thing like this is how everybody's showing you the examples.
So your in file is just the front of it?
I'm sorry?
Your in file is just the front of the in?
Yes, it's just the face of the, because this is not 3D. So.
I know it's not 3D, I just...
Oh, you mean the foreground? Yes.
It could have been side, and the side was like a...
Oh yeah, no. This is the full image. Just in fact, why don't we look at it quick? There it is. That is the image that we were talking about. So it shows you the full. Is that what you were asking?
No, it's different. How come the one side is not brighter than just the one?
Because the image itself actually has shading built into it.
So the original.
This is the original that we're looking at. There's the brighter version.
Yeah. So everything boosted, but the left side was lower to begin with.
The left side was lower to begin with, exactly.
You didn't want that to get brighter. You would just start with an image that didn't have it.
Yep, or you would create a mask for the left side so that you're only increasing the values on the right side.
Or you would pick colors to get brighter only if they were already above a certain level.
That's also true. Yeah, there's lots of ways to do this, because when it comes down to it, it's all just math. That's, we're just flipping switches on pixels here. So it's very simple math.
Question, is this artwork your own?
Yes. Well, it's not, I didn't write, or I didn't draw it, but
Okay, that's what
I commissioned
wondered if
it.
you had created it.
Yeah, I commissioned it.
I was going to say it's good. So.
Thank you. Yeah, no, this particular building was drawn by an artist out of the UK called Julian Harris. So, anyway, so yeah, oops, there's our brightness. So you can see 25% brighter. it's not that big a deal when you look at it like this. It's not, it doesn't seem that much brighter, but it makes quite a difference. So now if I went 100% brighter, it would be totally washed out, right? So, okay. Any questions on this? Any further questions before we move on? You want to see the code again, quick? Okay. All right.
If it was 100% brighter, it wouldn't be that black.
Well, yeah, it wouldn't be completely white yet, but yes, it would be.
Well, black.
Yeah, well, and some of the stuff like the roof would be pinkish color rather than it would be more like a salmon color than it is now because it would be more washed out than it is. Yeah. And the sides of the house would be completely white because they're already pretty damn bright. So if you did so anyway. Okay, so we got our brightness. Now we come to the really complex part, which is generating. I'm going to cast a shadow off of this two-dimensional object, right? So two-dimensional objects don't cast shadows. This is not a 3D engine. As one of you mentioned earlier, am I using a 3D engine to do this? And no. We're tricking it. So you can't cast a shadow off of a two-dimensional object and have it look good, except that you can through little tricks. So I'm going to show you how I did that trick. It's a little bit finicky. There's a lot of steps. So hold on to your seats and ask lots of questions. All right. The first thing is, of course, have the foreground image separate from the background image, just like before. That's the easiest way. You can, of course, mask out the foreground image and then do it the other way. That's going to be way easier in Photoshop or something like that than it is programmatically if you're going to have to create the mask. Then we need to analyze the image, looking to see if there's a natural light source in the image. Like, does the image already have shadows built onto it? And then determine a realistic shadow location to cast. And when I started doing this, I actually took out my phone and put some stuff down on my table and started, put the flashlight out basically and started looking at how the shadow was cast from a different angle so I could try and get it right for this image. It helps to take that, bring it into the real world a little bit. Then we want to generate a fake shadow, and finally we will place the original image over the fake shadow so that it looks like it is casted, right? So.
And the big reason to do this programmatically is you can then put the end in the woods or on rocky terrain of the moon and still have it look convincingly there.
That would be a reason to do it. My reason for doing it is not so that I can put it into different environments, but rather so that I can do it with the 60 other buildings that I have to do this with. I write it once and it'll cast a shadow for all of them. So yeah, I didn't want to have to manually do that. That would take forever. So
Also,
anyway.
if you add images in the future.
That's right.
Or you can even change the time of day.
Yes.
Exactly.
If I would have
These are
had
your morning tiles.
the problem with the time of day is you can absolutely change the time of day and you can have it change. The problem with it is though that there are certain shadows already built into this image, so I would have to cast new shadows on the face of the image to deal with time of day.
You just have to develop a mechanism for tiles that can visibly change.
Yeah.
I'm looking forward to your Imager 3D talk next month.
I'm not going to do an Imager 3D. This is about as far as we're getting without going 3D.
Built into the tiles.
All right. So
Maybe we could
Basically move the subject from one side to the other.
So, as I said, we need to analyze this image to see if there is a built-in light source here. And I can see that there is a shadow on that roof right there, which means that my light source must be coming from the right-hand side, kind of behind the house, to be casting that shadow on the front of the roof. But yet, I still got visible light on the side of the roof, right? So it's got to be kind of behind and to the right.
And you're doing this analysis programmatically?
Yeah,
No,
so
I'm doing this analysis.
Okay, I thought
So
you
you're
were
just
okay.
looking at it yourself.
I'm just looking at it myself.
Okay.
All of the images are rendered, in my case, all of the images are rendered to have the same light source.
Okay.
I just had to figure out exactly where did the artist think the light source was
Right. Okay. Gotcha.
when he drew these.
That's what we were curious about.
Yeah. No, analyzing this would be a much more difficult thing. So I'm also noticing a shadow under the ledge of this building right here, right at the top. There's a little bit of a shadow casting down, which means that that light source can't be behind and to the right. It must be behind and to the right and up, right?
That's just,
What's that? Just mascara? So I think that my light source is roughly there. Okay. Now, in addition to that, I think that
Whoa, what did you just do?
I think that the light source is roughly going to cast the shadow like that. Okay? So let me back this up for you. So again, we got a shadow here, and we got a shadow there, which indicates that our light source is up there. And so that means that if it casts a shadow onto the ground, that shadow has to come forward and to the left. Right? Okay. Everybody following the logic here? Whether you agree with where I've positioned the light source or not?
If that's what the light source is, that would be correct.
Yes. So, anyway, that is kind of what we have to do now. Now that we've done our initial analysis of where the light source is already in the image, now we have to actually generate a shadow for that light source. So, this is the code to do that. There's a lot here, so I'm going to break it down step by step for you. So the first thing we need to do is actually create a black version of our house. That will become our shadow. So that's basically the reverse of what we were doing before with the mask, or with the brightness. We're just going to turn the brightness all the way to 0 for every pixel, right? So that's all I'm doing. Does that make sense?
see, senor.
Okay. It's pretty straightforward. So then I'm going to shear the shadow. Basically, I'm going to make the whole thing go like this, fall over. Okay. Now, you'll notice that the shadow isn't there anymore. As soon as I sheared it, it went away. And this confused me at first. And then I realized that the shearing process actually pushed the shadow out of bounds of the image that I was looking for. So I actually have to move the whole thing back.
Yeah.
So so at first I did shear, which is that first line up there, and then I did translate, which moves the whole thing down 580 pixels and to the right 580 pixels, and then up 240 pixels, right? So now I've got my shear, so I can actually see what the heck is going on. Okay? Are you familiar, or are you getting?
So what shear did is it went like that, and what you wanted is like that.
No. Shear did what you're seeing here visibly, this little weird house that's laying on its side. That's what shear did. But in shearing, it also pushed it out of bounds of the image.
Yeah.
So,
That's what I meant by that.
Oh, okay.
Instead of just that.
yes. Yeah, it didn't rotate it in place. It fell over. Right. Yeah. So, I just had to get it back into bounds so that we can see what it's doing. Because shadows are these weird things that bend, right? I can't just take the black image of the house and bring it forward and we're done like I did in my original rendering. It has to fall over onto the ground because the ground is flat. So it has to, we have to take the whole house and just topple it sideways and twist it up a little bit to deal with the fact that it's rendering on a flat surface, that's perpendicular to the house. A different flat surface perpendicular to the house. But as you can see, this still isn't looking quite right. We don't have quite enough twistiness in here yet. We've still got a little bit more. So the next thing I'm going to do is I'm going to rotate the shadow a little bit. We need to twist it around a little bit. So we're going to do that. And so now it looks more like the shadow, or it looks more like the house again. We're not quite so weird shaped. More like the house, but the house is bent over a little bit. But that still doesn't take into account the fact that it's casting on a relatively perpendicular surface. So now we need to skew the whole thing too, which will squash it down a little bit, right? And so for this we did rotate 20 degrees, okay? And you'll note that this matrix transform, you just take all your different transformations and add them together, and that will create the matrix by which it will move these pixels from one place to another.
Oh, wow.
Does that make sense? Okay. So you can add in as many of these transformations as you want, and then do it. All right. So that, by the way, is ridiculously powerful. The amount of crazy stuff you can pull off because you have this full transform library in Imager is amazing. This is just scratching the surface. Okay. So the next thing we need to do is we need to squash it back down a little bit so that it looks right. So the light's casting it, it's going to be squatter and fatter than the whole house, and it's also going to be laying down a little bit. So it's going to create this little effect that we're looking for here. And you might think to yourself, you know, that still doesn't look like the shadow, but it really does when you get to it. We just haven't done everything yet.
Like a shadow once the house is there.
Right. That's the problem, is you're looking at it without the shadow there, or without the house there. So, because in real life, you never see just the shadow of something, you see the thing that is casting the shadow. So it might freak you out a little bit, and you're like, that isn't right. Okay. So, what's that?
Unless you got some crazy polarization.
Yeah, crazy polarization. So now we need to put it all together. So we're just going to use the same old things that we've been using, which is compose. We're going to load in an image. We're going to compose. We're going to compose again, and then we will write it out. So this is what we're looking at. We're putting our shadow onto the grass. And you'll note here that on the previous screen, that is still black. It's 100% black, right? But when I bring it forward, I am doing it at 10% opacity. So it's actually just creating that kind of shadow effect on the grass rather than, you know, we're not fully opaque. Shadows aren't fully opaque.
If I went to all that effort, I think I would dial up the opacity.
Yeah? Yeah. just to make sure.
Appreciate the damn shadow.
So is this the two squares of the picture? Are they the same size?
Yes. Yeah, if they weren't, I would have to put in some TX and TY values to position when I was doing these compositions to say where they go. But I'm creating all the images the exact same size because that makes it much easier to lay them over the top of each other. All right, so, and then finally we just need to put the house on top of it, and it creates a relatively convincing shadow. It's pretty amazing how easy that was. I mean, not really, but that was still pretty cool. So this actually works out quite well. Let me go over here quick and. Oops. Let's see if I can stretch these out a little bit. Okay, so there's the fence. You can see the fence. Oop, God, and then I screwed up my stretch here. All right, so then we'll move on, and you can see there's a little bit of shadow being cast on each one of these. You can see the, you know, even the little post is casting a shadow. The smoke is casting a shadow, and the smoke is already partially transparent, so it's even more transparent when it gets laid down onto the ground. Oop, did it again. All right, so, you know, we've got the roof line there casting a shadow. Our fence, smoke again. Even this little drying rack right here. So this is a hunter's cabin, and there are skins out there drying, and so you can see the rack casting a shadow with the skins into the ground, and the ladder is casting a shadow. So there are some places where it doesn't work perfectly. Like right here is one. This little thing in the foreground here, this little trough, is casting a shadow way over here, right? But in most cases, you're not going to notice. So
Downside of 2.5D.
exactly, this is the downside of 2.5D. But I mean, look at that. That is amazing,
Yeah.
right? So, and I did this all with the in. So I wasn't actually designing for any of these other images. I did it with the in, and then because I did a decent enough job with the in, it works on basically every other image.
Ooh.
Yeah.
Isn't that fantastic?
Yeah.
Yeah.
The ladder shadow is again.
The ladder shadow is off a little bit. It should be moved over just slightly. But yeah, it still looks pretty fantastic. So again, these could be tweaked per image, but then I'd be going back and doing it manually, and the whole point of this was to go through all these and do them automated, right? And therefore, it adds this nice little detail that you might not even notice. Your eye will notice, your mind's eye is going to notice this, but you might consciously not notice what's going on. So, so anyway, that's that. Going back here, we're pretty much done. We have put it all together. So this is the code, once again, all together, all of the different pieces to create that shadow. Any questions about shadow creation, about what I did there?
So this is a hardcore tabletop game.
Yes, this is for a tabletop game.
So how big are the hexagons?
The tiles are 1.25 inches across from vertex to vertex. They're fairly small.
You're not even gonna notice the
Exactly.
So
imperfections.
Yes.
the sear is the one that moved the house.
Out of the viewport. Yes.
That makes
It's
it
the one
fall
that's
over.
tilting the whole thing to make it all fall over.
Right.
And it's also moving it out of the viewport, which is why we have to do the translate next to move
But when
it
you
back
took
in.
the full color house and then you made the more translucent full color house, it looked like the house, nothing else happened except the house just moved.
Yeah, because
What
that
was
wasn't
that?
done in Imager. That was just done in my presentation software. I just wanted to show you that we're going to cast the image or cast the shadow out front.
Yeah, because it seemed like it was handling all the pixels uniformly rather than using the pixels, because the pixels that are closer to us, that are down in the image, you know, if they could be multiplied differently,
Yes.
proportionately, then anyway.
Yeah, and you could do that if you wanted to spend a crap ton more time.
Right.
Because, like I said, the Matrix software and the Matrix 2D library allows you to do all kinds of stuff. I wanted to get this done because this is one of those details that you might not even notice, especially, you know, what we were saying here, that, you know, with the rendered images here, the tiles that you're going to get for this game are only 1.25 inches across, so that this is a really tiny detail. This is for those people that look at all those
So
little
we're way
things.
zoomed in on this.
Yeah.
Yeah, and you'd have to go full on 3D to get every shadow perfectly kind of
Or tweak it per building. Yeah. It's just not. This is trying to do something really cool with images I already had that weren't intended to cast shadows.
So the next step then is a bump map for the terrain,
Yes.
so that the shadow rolls over appropriately.
You could do a bump map for the terrain, but I'm not going to do that.
And that's something you were going to do.
Yeah. So anyway, we have, through what we just described here, we've achieved what I set out to do at the beginning of this, which is we turned this image on the left into the image on the right. And the reason that I needed to do, obviously for the tiles themselves, the shadow is important, the brightness is important, but the reason that I did the outline, you know, the mask and the bevel, is actually so that I could have nice images that looked good in the manual without taking photographs of every single image and trying to get so there was no glare and make it look perfect. Put these tiles into the manual, then, you know, they just work. So it's really cool to be able to render all that automated, so I don't have to take photographs of all this and then, you know, get rid of all of the background images and everything for everything. So with that, this game is actually going to be on Kickstarter next week. This is called Hamlet Builder Pro, and I hope that you will consider backing it.
Will you send out an email?
I will send out an email, sure, if you like. And yeah.
We'll suck it.
Are you? Good. So yeah, this is basically a little city building game, and you got to see some of the different buildings that you're building into your cities. So
I love gamelets. What was the T-shirt?
I love Hamlets.
Hamlets.
Yeah, I love Hamlets. And he's got a little Hamlet snow globe, and you know, they were just at a Hamlet theme park. Clearly.
Oh, yeah.
It was a tabletop event.
So, any other questions? Anything we should go back on? Do you want to actually experiment with some of the code, or you feeling pretty good about it?
I guess other than the stuff you covered, what are some other cool things that you've been dug into?
Basically, you can do anything with Imager that you can do with Photoshop. I haven't run into anything. Actually, I have run into one thing. I cannot draw an ellipse, an oval. So to draw an oval in Imager, for whatever reason, I don't know why they omitted this, but you draw a circle and then you do a matrix transform on it, or just a scale on one direction. And
Well, yes, you could, because you have that matrix transform. So
yeah, but you're working with raster, not vector, so you're gonna get ugly stuff.
well, you just draw it bigger than you need and then scale it down.
The other thing that you could do, if you really wanted a good one, was draw pixel by pixel.
You could.
It's a relatively simple algorithm.
Yeah.
So I did it back in high school.
And rounded corners on your hexagon. This seems like a perfect opportunity to enhance it.
Well, that was his project. He made that module.
Oh, Imager is yours.
No,
No,
Imager is not
no,
mine. Imager,
oh,
Imager draw hexagon
The
is
hexagon
mine.
thing.
Oh.
That was, I wrote that because there's a polygon function, but drawing a hexagon to be proportionally correct is actually quite difficult. Like, so rather than having to figure that out every time I need to draw a hexagon or copy and paste, I just created a module and threw it out on
You just need to add
CPAN.
around
It's
the
like
corner
squaring
of
a
the
circle.
What's that?
It's like squaring a circle.
It's like squaring a circle, yes. So yeah, no, I could absolutely add rounded corners to that algorithm if I had a need for it. And maybe I will do that at some point. But that's one of the cool things about Imager, is that there is this library ecosystem out there of all these crazy things that it can that people have added. And I think I did a presentation a while back on showing some of the different crazy things that are out there. But
Who wrote Imager? Do you know anything?
Tony something, I don't remember his name.
And did they do the C and the Perl?
I believe so, yeah. I think he did both. Yeah.
That's impressive.
The
And
Imager
especially
library
not
is-
having GE or any other dependency.
Yeah, how fast it is really impressive too. And all the font manipulation stuff that you can do with it.
Oh,
Like
really?
they have a font wrap module, for example, that'll you give it a bounding box, and it'll write the text into the bounding box so it doesn't go outside that,
That's
and automatically wrap the text. It's really cool to have that kind of thing. So normally you have to, like in ImageMagick, I always had to calculate those bounds myself, so which is a pain. So anyway, could you hit the